Since the beginning of my sophomore year, I've been working at the Engines and Energy Conversion Lab run by the Mechanical Engineering Department. And that lab, you can do everything. Right now it's kind of culminated where I'm the student leader in charge of the installation of the largest engine yet. It weighs 110,000 pounds. I'm in charge of bringing it into the building, make sure that our foundation will support it, all the systems will support it, and getting it up to the point where it will run. I've been able to look at emissions analyzers and help take them apart, and it's great because rather than just looking in a book and be like, okay, well, this is why it works, instead you can look in the book and be like, oh yeah, well, there's a theory behind it, and then you can look at an engine and be like, okay, so that's why it works. And it really helps me because I am such a hands-on learner. There's 3 main engines. We have a GMV engine, we have a Waukesha engine, and then the Clark engine, which is the engine I'm in charge of. The GMV engine is very neat because that's what the lab was founded on. I mean, I think they put it in probably about '93. And on that engine, they've tried different types of injection systems and different technologies to help retrofit this engine to make it cleaner and to make it more efficient in power. And these technologies that we've tested, it's so neat because they've been able to apply them out in the real world. So out in the natural gas industry, they can now use these technologies to help clean up the emissions and make them more powerful. And it's just neat because the Engines Lab has been a really, really big part of it. I did a senior design project this year where we helped retrofit a snowmobile to make it clean and quiet. And it was very exciting and a lot of fun. And actually, the team 2 years ago implemented a direct fuel injection system. And then that cleaned up the emissions. It amazed everyone in the snowmobile world. Last year's team, we were able to build on it. Well, last year's team was able to build on it, and they took the engine out and put it into a new chassis. So they put it into a new snowmobile chassis, which made it lighter and more fun to ride. And then this year, part of the competition, besides being clean, you have to be quiet. And that's the big thing. They're coming out with these new 4-strokes that are clean and quiet, but the consumers like the 2-strokes. So it's really important to prove that, hey, you really like this style, you really like the feel of this engine and what you're used to. Well, we'll clean it up and we'll make it quiet. And so this year we really concentrated on noise, and we were able to knock it down to 2 decibels below our cutoff, which no team from CSU had ever done. And so I spent a lot of hours on that this year, and that was just a huge part of it. But it was rewarding. It really was. I mean, after all the work we went to a competition over spring break in Houghton, Michigan, where Michigan Tech was, and there was 15 other schools there. It's kind of neat just to see what a bunch of college kids have come up with.